We have two organ pipes, and these organ pipes are open, which means at both ends of the pipe there's going to be what's called an antinode. Antinodes are places where the waves can vibrate back and forth very far. They have the biggest amplitudes, whereas a node is a place where the wave has a zero amplitude, basically, the standing wave, that is. So based on that, we can look at this. There's two pipes, one's shorter, one's longer, and the shorter pipe is 2.4 meters long. And we know that the fundamental frequency means there has to be one node right in the middle there, because there has to be antinodes on both sides. And that means that the biggest wave that we can draw is 1/2 of a wavelength long, right? If you look at this, I'll do it in red. This is going to be 1/2 of a wavelength, because the rest of it would be going beyond the pipe there. So that means that the length of this thing must equal 1/2 of the wavelength. The length of this pipe equals 1/2 of the wavelength. So we know that the beat frequency is 6 hertz. Beat frequency, a beat is when you're listening to two frequencies played at the same time, you hear kind of like a wah 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 wah, and the frequency of that is the beat frequency. So the way that you figure, or the way that this factors into the problem, is we know that the frequency of the shorter pipe, which will have a higher frequency, so we'll call that f2.4, minus the frequency of this other one, which we'll just call f question mark for now, is going to equal that beat frequency. So this is going to help us figure out the length of this pipe, which is ultimately what we're looking for. So the way that I'm going to solve this is I'm going to look for the frequency of the standing wave in this first tube. Then I'm going to subtract 6 from it to get f by itself, right? Because f2.4 minus 6, if I just subtract 6 on this side, is going to equal that question mark frequency. So if I find out what the frequency of this one is, subtract 6 from it, then I'll know what this frequency is, and then if I know the frequency, I can go backwards and plug it into the equation to figure out what the length is. So this equation right here has wavelength. What we're going to need to do is use the wave speed equation to substitute to figure out what frequency is. So this equation says that the speed of a wave, in this case a sound wave, is equal to the wavelength of the wave times the frequency of the wave. Well, I have wavelength here, and I want to substitute that out because I don't really care about the wavelength at this point. So I'm going to solve for wavelength, which means I divide frequency on both sides, and so I get the speed of the wave divided by frequency. And the speed of the wave of sound in air is given to you in the textbook as 343 meters per second. So we can basically substitute all of that in. So I have 1/2 times 343 divided by f, which we don't know what f is equal to 2.4. So we're finding the frequency in this first pipe. So now I just have to do a little bit of algebra. I'll multiply by 2 on both sides. That'll give me this by itself, so 2 times 2.4. And then I need to basically get f by itself. So I'll bring f over to this side and divide that on that side, so I get, excuse me, there we go, 343 divided by 2 times 2.4 is equal to the frequency. So let's go ahead and punch that in the calculator and see what we get. And I get a frequency of 71.458, repeating, just leaving all the numbers there for now. So that's the frequency of this pipe. Now we just said earlier, knowing that the beat frequency is 6 hertz means that these two frequencies are 6 apart from each other. So the difference between them is 6 hertz. So there's two ways you can go from it. You can either add 6 hertz to it or subtract 6 hertz to see which way it goes. Now I'm saying that we're subtracting 6 from this because we know that a smaller tube is going to produce a higher pitched noise, so therefore I'm going to subtract 6 from this. If you didn't know that and you added 6 because you were like, maybe I just add it, what you're going to get is a length that's shorter than 2.4, and then you're going to know it's wrong because the question asks you what is the longer tube. So if it ends up being shorter, that's going to be wrong. So that's where you're going to want to check your work. So then we just do subtract. And when I subtract 6 from that, I get a frequency of 65.4583 repeating hertz. And then we need to plug this back into our equation here and solve for what the tube length is going to be. So the equation is that the length is equal to 1/2 the wavelength. I'll just start with here again because I want length by itself. And wavelength is equal to the speed divided by the frequency. And we know that the frequency, the speed is 343 because they told us that. And the frequency we said is 65.4583. 65.4583 repeating. And that's going to give us our length. So let's go ahead and do that. So 343 divided by that frequency and then multiply that by 1/2. And I get a length of 2.62 meters, or if we're using 2 sig figs, it'll be 2.6 meters.